Okay, I can solve multi-step word problems modeled with tape diagrams and assess the reasonableness of answers using rounding. So we're going to round our answers today. We're going to round our numbers and we're going to compare them to the actual standard algorithm that we use to solve the problems. Okay? So let's start with a little bit of a review. I want you to look at these three numbers. What is the place value of the digit that's changing? Look at the 10,000s, look at the thousands, the hundreds, the tens, the ones. What place value is changing? Okay, if you look at the 10,000s, you'll notice that it says 4, 5, and 6. The thousands, all zeros. The hundreds, all ones. The tens, all zeros. And the ones, all zeros. So the place value of the digit that's changing is 10,000's place. When is that important to know that? When do we use that concept? Why do we need to know sometimes what place the number's changing? Let's look at the next slide and see. What number comes next? Sometimes it's important to look at a pattern so that you can order your numbers from least to greatest or greatest to least. Also, it's important to always know what place value the number's changing when you're comparing numbers, saying greater than, less than, equal to. So when comparing numbers, you need to know the value, the place value where the digit is always changing. So we have 40,100, 50,100, 60,100. What number comes next? Let's go back to the place value chart. In the 10,000s, we have 4, 5, 6. Well, what comes next? What comes after 6? I want you to write that number. Make sure it's written exactly as the other ones. The only number that should be different is the 10,000's place. So go ahead and write that in the space below. Okay, let's look at the next slide. What is the place value of the digit that's changing? Whoa, this looks like a huge number. But if you break it down and you look at every single spot, the 100,000 staying the same, the 10,000 staying the same, the thousands are staying the same, the hundreds, not the same. The tens are the same, the ones are the same. So if I were comparing these numbers, what place value is the digit that's changing? Where is that? Go ahead and circle the place where the digit's changing. Okay, let's look at this slide. What number comes next? We're going to go back to the previous slide. Look at the pattern. What's going to go next? If I were to write a number below, what would go next? All numbers would stay the same except the number in the hundreds place. Is it getting bigger or smaller? I want you to write the number that comes next in the space below. Okay, so you just learned how cotton is made, and that's good because today our first problem is going to be about a factory. Not only does a factory make cotton, it makes silk and it makes wool. Now, in 1 year, a factory used 11,650 meters of cotton, 4,950 fewer meters of silk than cotton, and 3,500 fewer meters of wool than silk. How many meters in all were used of the three fabrics? Let's go ahead and go to the next slide, and it says that we need to underline the important information. So go ahead and pause, underline the important information. Okay, when I read through this, I felt that the important information was that a factory used 11,650 meters of cotton, 4,950 fewer meters of silk than cotton, and 3,500 fewer meters of wool than silk. Now, there is one very, very super important thing that I did not underline. What do you think is left that I need to underline? It's the question. You have to know the question to even know what's important in the problem, okay? The question is, how many meters in all were used of the 3 fabrics? So, we have cotton, but it says silk had fewer meters than cotton. So how long is a silk bar going to be? Is it going to be longer than cotton or shorter than cotton? Let's think about that. It says fewer meters of silk. Fewer is the same as less than. It's going to be a smaller bar. Let's look at wool. Wool had fewer meters than silk. So is this bar going to be longer than silk or shorter than silk? What is the key word that we keep seeing in this problem that's going to tell us how long our bars need to be? The key word is fewer. So the shortest bar that we'll have when we make our tape diagram is going to be wool. And then the next bar would be silk. And our longest bar of all will be cotton. Also, when making tape diagrams, it's important to look at the information. A factory used 11,650 meters of cotton. We know exactly how much cotton was used. What you need to do when you're reading these problems is find the place where it tells exactly how much was used, how much was gained, the total, okay? That's going to be our total for this problem. Everything else is going to be related to our 11,650 meters of cotton. Okay. So in 1 year, a factory used 11,650 meters of cotton. Look at our cotton bar. Label it. Okay, how do you think the silk is going to look? And how do you think wool is going to look? Go ahead and try to draw it out and see if yours looks like mine when I finish solving this problem. So go ahead and pause it. Fill in where you think the bars need to be filled in, and you can even try to solve it. Okay, so when I labeled my cotton bar, I knew exactly how much cotton was used. So I don't have to have a variable because I know exactly. 11,650 meters were used. Okay, but what do we know about silk? We know it is 4,950 fewer than cotton. How would we show that on the tape diagram? How would you show that? Okay, so what I did on this problem was I made the cotton and the silk both the same length. And if you notice, I added yellow to my silk bar because it's showing that that's how much I'm taking off, okay? I'm taking off 4,950 from 11,650 to get my answer for my blue bar. So go ahead and subtract that and see what answer you get. 11,650 minus 4,950. Okay. What do we know about wool? We know that wool is 3,500 meters fewer than silk. How will we display that information? Can we add to our wool bar to go to the end of the silk bar? Now remember, the yellow part is representative of cotton. So our silk bar is blue. So if we extend our wool bar to match the silk, then we'll know what to subtract. Okay, because we've already found the answer for silk. You found that in the last problem. So now you'll take your silk bar and subtract 3,500 to get wool. And this is how that would look. Notice how cotton, silk, and wool are all the same length now. Okay, let's solve the problem. We made each bar the same length as cotton because we know how much cotton there is. We know that we have 11,650, but silk was 4,950 meters fewer than cotton. So we would subtract 4,950 from 11,650. We know that wool was 3,500 meters fewer than silk. Now, if we wanted to, we could add 3,500 plus 4,950 to find out how much we need to take away from 11,650. Or we could find out how much silk we actually used and then subtract 3,500 from it. It's your choice. However you want to do it, it's fine. We can now see that silk plus 4,950 equals 11,650. Okay, I've already said it multiple times. What can we do to figure out how much silk there is? Go ahead, solve it. If you haven't done it yet, go ahead and write the number in the blue silk bar of how much silk we actually have used. Okay. So on this next slide, I'm going to work through the problem with you. And I want you to go ahead and solve it along with me so that I know that you understand what I'm doing here. So 0 minus 0 is 0. 5 minus 5 is 0. Can I do 6 minus 9? No, I can't. So go to the neighbor and I borrow 1. Where does that 1 go? It goes in front of its neighbor. So 16 minus 9 is 7. Don't forget your comma. 0 minus 4. Can I do it? Nope. We gotta go to the neighbor, borrow 1. What happens to the one I borrowed? It sits in front of its neighbor. So 10 minus 4 is 6. So how much silk was used? Let's look at the next slide. We now know that 6,700 or 6,700 meters of silk was used. So now we have everything we need to know for cotton. We have everything we need to know for silk. The last thing we need to know is wool. So let's look at the next one. Okay, it says, is the answer correct? How can we check? How can we check? How do we know by looking at this bar that 6,700 or 6,700 meters is correct? Now, if the silk bar were the same length as cotton, it would equal 11,650. Can we add 6,700 plus 4,950 meters? Yes, we can. So if we add those two together, we should get 11,650. Okay, let's look at the wool. Wool is 3,500 fewer meters than silk. How will we solve this problem? How are you going to solve that? Go ahead, I want you to use a space, find a space on this screen right here, and I want you to solve it. And if I were you, instead of adding 3,500 plus 4,950 and then subtracting it from 11,650, we now know how much silk we have used, so we can actually take 6,700 minus 3,500. What will your answer be? Let's look and see. 6,700 minus 3,500 is 3,200, or 3,200 meters. Okay, so now we know how much cotton we've used, we know how much silk we've used, we know how much wool we've used. Do we need those extenders on our bars anymore? Nope, we can cross those out. We're done with them. Now, the main question. How many meters in all were used of the three fabrics? In all. In all. What are we going to do? Think about that. We're going to have to add cotton, silk, and wool. Make sure you've crossed out the extenders on our bars so that you don't get confused. Okay. How will you find the answer to the question? What are you going to do? You're going to add them. So, how many meters in all were used of the three fabrics? 21,550 meters of fabric was used. Okay, let's look at the next problem. The shop sold 12,789 chocolate and 9,324 cookie dough cones. Sounds good. They sold 1,078 more peanut butter cones than cookie dough cones and 999 more vanilla cones than chocolate cones. What was the total number of ice cream cones sold? The answer is 46,303. You're going to work on your own to solve the problem and see if you get the same answer. Use tape diagrams. Okay, so go ahead, pause. I want you to try to solve this problem. Okay. Let's look at this problem. I highlighted my important information. 12,789 chocolate, 9,324 cookie dough, 1,078 more peanut butter cones than cookie dough, 999 more vanilla cones than chocolate cones. What was the total number of ice cream cones sold? So we know the total of chocolate cones. We were able to go in, we were able to make our bar exactly 12,789. And then you need to look, do we have another exact amount? Yes, we do. 9,324 cookie dough. So we were able to go in and make those 2 bars. And look at how they've been made. Okay. So they sold 1,078 more peanut butter cones than cookie dough. So we have our peanut butter, 1,078, and we're going to go ahead and add our cookie dough to it. And that gives us 10,402. Now, it says 999 more vanilla cones than chocolate. It doesn't say fewer, it says more, so that means our bar is going to be longer. We know we have 999 vanilla cones, and we know that we're going to add that to the chocolate amount, which will give us 13,788. The question is, what was the total number of ice cream cones sold? How do you find that out? You're going to add all of the numbers together. Is this a reasonable answer? If I were to round, let's say I were to round to the thousands place. So I would have 13,000 plus 13,000. So I have 13,000. Let's do this. Let's write out. Plus 13,000 plus 9,000 plus 10,000. What does that equal? 9 plus 3 plus 3. So that's 9 plus 6. 9 plus 6 is 15. Plus 4. 45,000. Is that reasonable? What do you think? 45,000. Is that a good estimate for what we have here? I would say it's pretty close. If I would have rounded to the 10,000s place, I would have had 40,000. 45,000 is a pretty close estimate to the exact answer. So I would say rounding to the thousands place is a pretty reasonable estimate. Okay, by looking at the tape diagram, I can see we have two 13,000s, that's 26,000. We have two 9,000s, that's 26 and 18 is 44. Plus about 2,000 more, that's 46,000. That's close. Okay. Here's another problem. In the first week of June, a restaurant sold 10,345 omelets. The second week, they sold 1,096 fewer omelets than the first week. The third week, they sold 2,000 more than the first week. The fourth week, they sold 2,000 fewer than the first week. How many omelets did they sell in all in June? The answer is the restaurant sold 40,284 omelets in June. I want you to work to figure out how we got that answer. Don't forget to make a tape diagram. So, don't just solve this on your desk. I want you to solve it, start a blank slide, and I want you to do a screenshot of it when you're done solving it. Okay, you can go ahead and draw your bars on the next slide.